Cool. Hello, welcome everybody. We're here with some of the folks from the iEx.ec team, Gilles and Julien. Welcome, guys. Thank you for taking the time to join and speak with us.
Hi, Jake.
Hello.
Thank you for the invitation and giving us the opportunity to answer your questions.
Yeah. Cool. So we're very excited to learn about a little bit more details about your project. I know a lot of people in our community have been talking about it, so we'd love to get a little overview of what you guys are doing.
Sure. So first, how to pronounce it? So so you can pronounce it iExec. iExec, it stands for I execute in short. I like it because, from a developer perspective, it sounds like the name of a function or something like this. So in terms of marketing, at least for me as a developer, it sounds okay. So iExec, it's about decentralizing the cloud. So you have two aspects: one that is more business oriented, and one that is more infrastructure oriented. So business-wise, decentralizing the cloud, it means that we want to create a sort of market network or marketplace, if you want, but more market network for every businesses that are around cloud computing. Okay, so we are using the Ethereum blockchain to do this, technology-wise, and distributed computing. And by mixing the two, we are going to create this sort of decentralized marketplace where server providers, data centers providers, applications providers, data set providers can all interoperate and do business together. Okay, so you need a machine, you go in this marketplace, use this machine, you need an application, you go application, data set. So that's one aspect. And the second aspect is more, I would say, infrastructure oriented. And here, what's interesting is that this new kind of cloud is going to be very different than the existing one. The existing cloud infrastructure at the moment is very centralized. These are usually big, very large data center. And here, of course, we are going to have an infrastructure which is much more distributed. So that's very interesting. It opens, in my opinion, a lot of new opportunities. And yes, and that's it.
Cool. So what kind of businesses do you envision using this kind of network? Like, what is the demand for distributed computation as you see it today? And then why would such a business go to a decentralized offering versus going to something like Google Cloud or Amazon, etc.?
So yeah, that's a very good question. So we have identified three main categories of application and businesses that would require this new form of cloud computing. So the first one that is really identified, it's what we call the dApps. So dApps, those are those new distributed applications running on the Ethereum blockchain. And at the moment, when you're a developer and when you develop an application for Ethereum, you actually have a very few computing capacity. So you can deploy your smart contract, but your smart contract does not have a lot of storage, does not have a lot of performance when it has to execute a computation, etc., etc. So the first need is for those applications so that they can execute their demanding task off-chain. So you have your smart contract on-chain for doing the business, the business logic, if you want. And when you need to access bigger data, or when you need to run an algorithm which is not compute intensive, but because at the moment the threshold is very, very low, then you can execute that off-chain. So for it, it's a very important market in the sense that it's going to improve a lot the situation with dApps at the moment. Okay, so thanks to this new feature provided by iExec, a lot of we hope that many new kind of dApps are going to be able to execute on Ethereum. And so the application of what I call blockchain computing is going to increase a lot. So that's the first category. The second category is those what I call the legacy applications. So these are the applications that are now developed for the traditional cloud computing infrastructure. So the one running on, for instance, Amazon cloud and this kind of thing, and this kind of a cloud provider. And they would be, I mean, they would move to iExec because iExec is an open market. And here you can imagine that providers having more competitive solutions could be easily, discovered by developers. So you have your, let's say, your application running on Amazon EC2, and then going to iExec, you can discover that some providers actually can offer you a much better price. And so you would move from Amazon to go to iExec because some provider maybe have more cost-effective solutions. So that's the second category. And here, of course, the kind of applications, everything that is around, let's say, big data, high-performance computing, and this kind of simulations, deep learning, machine learning, simulations of bioinformatics, all these kind of things, financial product, etc., etc. And the third category, which is more perspective at the moment, but I think it's going to be very important, are the applications for which we know that in the future the centralized cloud as it exists now is going to be a bottleneck. Okay, so here think of everything that is around IoT with a lot of data. So in the future, it's already anticipated that there are going to be a lot of devices connected to the internet, and those devices are going to produce a huge amount of data. It's already the case, you've heard about big data, okay? And in the future, what's going to happen is that the situation at the moment is that those devices have to send their data, back and forth to the centralized cloud. And in the future, this kind of solution is not going to be sustainable. And here it's everything that is about, so it's called usually fog computing, edge computing, dew computing. And so these are the next, so at the moment it's not yet an issue, but it will come very fast, I guess. And industrial, there are several industries which are already involved in this next generation. So for us, it's now a perspective, for now, but in the future, the distributed cloud proposed by iExec is really one of the solutions. That this is for sure.
So that's very interesting. So you see, you're making kind of a forward-looking assessment, and you kind of foresee that the centralized cloud providers and solutions we have today will basically, are you saying they won't be able to scale with the needs of a giant IoT network that we will have?
Yes. For some applications, yes, definitely. It's going to be an hybrid model because you still need the centralized cloud for many things because it's all well connected. You can have massive storage, etc. But you're going to need an additional infrastructure, much more distributed, where you can offload part of the computation really near to the data. And here, everything which is about geo distribution, finding. So it will be about for those connected devices, you must give them the ability to find near to their place, network-wise, some additional computing capacities to do, a part of the processing. So part of the processing is going to be certainly a lightweight processing, like filtering, aggregating, clustering data, this kind of, a little bit of deep learning and these kind of things.
And so are you basically saying that when these new resources will suddenly begin to be required, are you kind of saying that a decentralized network can first of all grow larger perhaps than a set of Amazon data centers, or grow faster, like to meet the demand of that market?
Yeah, the problem is that at the moment a significant part of the cost for running, this kind of application, running the internet at the moment, is really about data. So data transfer when it goes through the network, and data storage, actually more than raw computing power. So it will become more and more of an issue. And so alternative solutions are going to be, people who need alternative solution compared to what exists now. So at the moment, for instance, people who are, industries which are involved in this, future fog and edge computing, it's basically the telco provider and the network provider. So the network vendor such as Cisco, Huawei, AT&T and this kind of thing. So it's also a shift in the business, and so that's it. It also opens a lot of opportunities in the future. But at the moment, I mean, that's sort of long-term vision. But at the moment, we are first focusing on dApps. That's really in our roadmap, in the first year of the roadmap, and then the legacy applications, and later, maybe in 3-4 years, that's the grand vision. It will be for this kind of applications.
Right. So that was going to be my next question. Like you mentioned 3 categories. How would you attack them? And you kind of see it as, you know, you're starting in a niche where you are providing services to, you know, Ethereum-based decentralized applications, and then kind of growing out from there into, you know, more traditional business applications, and then eventually being ready for, you know, this kind of, you know, almost revolution or something in the explosion of these new devices. So that's very cool. I would love to hear a little bit about, you know, both of your backgrounds, and how did you guys come to the blockchain space, and how did you come up with this idea?
So please go ahead, Julian.
Oh, okay. Okay, so my background, I actually used to teach Chinese for 5 years, basically until Bitcoin, so April 2013, and then I joined. I worked on a project. It was a payment app, iOS app, and at this time I learned about crypto, a lot about the currency thing. And I learned, you know, this time I learned a lot with Joel Dietz, that you might know, and so it was, you know, super interesting experience. And at that time we also kind of saw Ethereum born, so it was exciting from day one, actually. And so then I joined a startup called Open Classrooms, which is one of the biggest e-learning company. I think it should be #1 in Europe. And then I really wanted to work on on a beautiful blockchain project that would make sense. And I just met Gilles at the DevCon 2. So I was just doing an interview of him, and then started to work on marketing aspects. Yeah.
So is marketing, Julien, is that your role in iExec?
Yes.
Cool.
Also, I mean, also, you know, also testing and yeah, basically, yeah.
Okay, cool. What about you, Jules?
So I'm actually a researcher in distributed system and parallel computing. So I worked at INRIA. INRIA is one of the main venue for research in computer science in Europe. It's a very big research institute. It's governmental. So we are about something like 3,000 researchers spread all over France. And so my background is really about distributed computing, with a focus on what we call desktop grids. So desktop grid is the idea of using a very large number of PCs distributed on the internet to execute a large application. So you may know that under the name of volunteer computing, and projects such as SETI at Home, Folding at Home, Boink, and this kind of things. So I've been doing this for something like 15 years, research in this area. So not only things, but also data management. So I address many of the issues and many of the research challenges associated with this this model of distributed computing. And so the co-founder of iExec is Hai Wu, who is a professor at the Chinese Academy of Science in Beijing. So of course I will leave INRIA to take full responsibility of iExec. It's a new life starting for me. So yes.
Why did you think? Like, why did you guys find that that a blockchain solution was preferable in this area rather than building some kind of, I don't know, other peer-to-peer network, to build out a market for computation, or just some sort of centralized company that would allow you to, outsource computation to third-party devices? Like, why do you feel the blockchain technology sort of drives the mission of the project?
Yeah, that's an interesting question. I think that before blockchain technology, so first there have been a couple of companies who tried to do that in the past, and before blockchain area, and most of them either failed or didn't really push this idea so far. I think that the blockchain makes the business much easier, and without the business, without this blockchain. Without the blockchain technology, you can't really do the business. And if you don't do the business, you're going to fall in some sort of, altruistic way of doing things. So as it exists with volunteer computing, it's people providing their machines for sake of science, discovery, and this kind of things. With blockchain, you can really do all the peer-to-peer business. And there's a lot of, a lot of the technical difficulties that disappear thanks to a technology like Ethereum. So payments, micropayments, machine-to-machine payments, payment for the API, etc., etc. So when I discovered Ethereum, I was really amazed about that, and it really gave me this opportunity to jump into it and try to see, how blockchain and distributed computing could come together and see, what are the potential for that. And the more I'm digging into iExec, the more I try to figure out the different opportunities. I'm totally amazed because it's going to change a lot.
So if I can add something. So yeah, we use this blockchain to for, well, like Gilles just said, for payment, and also for the marketplace that we will set up in the coming months, and also for funding.
Right. So you guys are kind of pointing to the fact that, in this system, because you have a digital, technological, efficient way of sending value across the network, that kind of confers a benefit to the market participants, right? So anybody who is providing computational power, they can just very easily be compensated in sort of in a traditional system. You can imagine that like someone would have to sign up and put in their credit card or bank account and get verified, and there's like a lot of sort of friction around that. So are you saying that sort of the core benefit here, at least in terms of the way the network works, is that by being able to distribute and compensate these nodes, are you creating like a lot of different efficiencies there?
Yes, correct. And even the application, when they are deployed on Ethereum, you have a set of new features that didn't exist before. The fact that you have this full transparency, you can log everything. There is the security. The fact that it's highly resilient. It's not something that existed before. Such level of a resiliency. Mm-hmm. The thing that applications are autonomous. They stay there forever. So all those new, at the moment, it's still a little bit difficult for a developer to understand the full potential of that. Okay, so we know that we know how it works for the smart contract, but an applications, a new kind of application, leveraging the smart contract technology, it's not yet very clear what, how big the potential is going to be. In my opinion, it's going to be really big because at the moment when you deploy a smart contract, you can just forget it. And the business is going to run forever. So each time you have someone interacting with your smart contract, then it creates some values. And you don't have to maintain anything. For a developer, it's really a dream. You don't have any servers, you don't have anything to maintain. And so that's really important. This notion of consensus also is kind of new in the distributed area. With the traditional cloud, you have SLA. SLA, it's a little bit different than a consensus. Consensus, you have a certain, you have nodes in the network that agree to work together, and at the end there's a consensus, and when the consensus is met, the payment happens. And so this, these are new way of thinking about how to develop distributed application. And in my opinion, is going to have a huge impact. Of course, we are still discovering it. I mean, it's still in infancy. It's still a little bit rough to use for a developer. The tools are not yet very elaborated, but I mean, it's just a matter of time. In a couple of months, years, it's going to be much more mainstream. And I think that iExec has a great role to play in this area, because we're going to help people to develop bigger applications that can use their legacy code, for instance. So if you do deep learning, that's going to be much easier to use iExec to monetize your deep learning applications through the blockchain.
So you mentioned, you kind of pointed to some of the inefficiencies of doing computation inside of smart contracts on Ethereum, inside of Solidity contracts, right? And of course, that deals with the fact that if you if you start to do something computationally intensive, that's going to get really expensive for you, because basically, like, the way that the Ethereum network works today is that you have all of the miners essentially executing and kind of checking the validity of the answer of the computation, right? And so in other words, there's kind of a trade-off in Ethereum between efficiency and trustlessness, right? So you're kind of proposing to create a network of side providers that are much, much more efficient at computing. Does that imply that you lose a little bit of that property of trustlessness that you otherwise have in Ethereum contracts?
Yes, I mean, yes. No, I think that we should, I mean, you can't execute any kind of application the way it's executed on Ethereum, because, I mean, for many reasons, it would be highly inefficient if you want to do that. And so, yes, our approach is to say, for everything that is a little bit compute intensive, then there would be a second layer of resource provider that would execute this application. And it's totally true that when you execute this application, the consensus can be very different. For instance, there are applications where you can totally afford to have some wrong results, a fraction of the results that are wrong. Not all of them, usually, but a fraction of the results that are wrong. Sometimes can be totally okay. If you run a Monte Carlo application, for instance, you can totally afford to have. So that's really important to imagine that for this, those other applications, you must have, the consensus must be a sort of framework so that you can adapt to the characteristics of each application and select the level of consensus you want for those applications. So you can let's imagine, for instance, that you have a category of applications that are, for instance, deterministic, and you can very easily verify a computation without running again the computation. So that would be one category. Sorry. You can imagine having a second category where you can have a threshold, such as I'm okay as soon as I have like 90% of my results coming back and certify, and then so that's really important. And then on Ethereum, what you can keep is the result of this consensus, because the result of the consensus is where you're going, is the one that is going to trigger the business logic.
So would you guys be able to walk us through if dApps and dApp developers are kind of the first target market? What are your users? What would they expect to see what would I expect to see if I was basically like a dApp developer and I wanted to kind of integrate with your network? And also, what would I expect to see if I was a provider of computation and hoping to provide services on your network?
So, as a developer, I think that the first important thing that iExec provides you is the fact that you can integrate your legacy code. So let's say that you develop So for instance, one of the examples we're going to release very soon, probably in the next week, maybe this week or the week after, is a chess engine. Okay, so you have a chess engine. It's called Stockfish. It's very well known. It's a very powerful chess
I'm
engine.
actually familiar with that engine. Yeah, it's great.
Yeah, you know that you played against.
Yes.
Okay.
Yeah.
So we have it ready, and for instance, so imagine you have this chess engine. It's already working. It's there, and you know you're developing a dApps, and like a chess game, and so your dApps is a chess game, and thanks to iExec, you can plug in your chess engine, and now you can play against Stockfish through a smart contract. So you put your next move in the smart contract, and the smart contract, gives you the opponent move. So this is typically the use case.
That's really interesting, right? Because if anyone is familiar with chess engines, then you know that the amount, so the quality of the move that the engine produces is proportional to the amount of computation that it is allowed to do. So in Stockfish, for example, you can you can compute for a minute or you can compute for an hour, and it kind of doesn't matter where you stop, because you will always have some answer as to how your piece should move. But the longer that you compute, the better that answer becomes. So that that's an interesting kind of observation to for applications where they don't have a critical time period, like for computation, and they can use the network sort of as required, maybe. So that's pretty cool. So do you mean that, like, if I was writing a chess dApp, I could basically be writing a Solidity contract, and then you would have an interface in Solidity where I could call out to the iExec network and do those kind of computations?
Yes. That's exactly the way it works. So we are giving you an API, and this API allows you to plug in your application. So the API is about describing a task. So when you describe a task, you say the machines on which it's going to execute. I mean, the set of machines. We are organizing our infrastructure in what we call workers pool, so pool of machines ready to execute the application, like a miner pool, if you want. It's very similar. Your application, so in this case, it's Stockfish, and your data. So in this case, there's no data for Stockfish. And as a developer, what you do first is to kind of register your application in sort of application registry. And once this is done, you can call this application to run a particular task using our API. So as a developer, that's really easy. I mean, Stockfish, it's typically something that can be in a single day. It's really, it's sort of a hello world for us, So I think thanks to this, it's going to open a brand new kind of application, because now it's going to be very easy for developers to, interoperate with their legacy application. You can, I mean, you can't imagine having Stockfish ported to Solidity and then run as a smart contract.
Right.
It's just impossible. Does that make sense?
Probably not enough resources to either store the data or that you would need for the search for the right move.
I mean, it would mean that all the nodes in the Ethereum would compute the next move. It would be just a nonsense. Okay. Right. But what is important is that at the end, you can retrieve your result through the smart contract. So what iExec does is it's deploying the application, deploying the data, doing the computation, and bring the result back to the smart contract.
Right. So that's an interesting point. So, like, as a Solidity, from the point of view of the dApp Solidity contract, it's fairly straightforward to have someone call a method, right? And then that method kicks off a computation in the iExec network. My question is, how does the result actually flow back? Is that the person or node who performed the computation, do they call back to the contract?
No, no, we are pushing the result back to the smart contract.
Okay, so who is the party that actually pushes the result back? Is it the node, or is it your application? Or
yeah, this is iExec. iExec does this. So
okay.
iExec basically monitors the smart contract that describes the task, and whenever it's a new, you have a function that allows to trigger the execution, and iExec takes care of pushing the result back to the smart contract. So you can read through the smart contract. And what's interesting, what is interesting is that, so we did a POC, not with a stockfish, but we did that with a Bitcoin vanity address generator. And this POC, what we tried to do, what we did actually, is, we did really an end-to-end proof of concept. So to trigger the application, you're first sending the iExec token, and it's really the iExec token that is used to, trigger the application, pay for the application, and go to the machine provider, etc., etc. So we are very confident that also the use of the token, the token can be, eventually the token, yes, totally usable for doing this kind of computation. So that was very, very important for us.
Cool. And so, and to go to the other side of the market, if I'm a provider of computation, how does it work? Do I, set up a computer, I run your client or something like that, and then, how are the prices of my computation set? And for example, like how does that work?
So first thing I would like to mention is the fact that in the iExec roadmap, in our roadmap, we are not opening now the market for server provider. So in the roadmap, first we are opening the market for the applications, and later for the server provider. So after 6 months, it's first the market for the application, and after a year, it's going to be for the server provider. So for the server provider, yes, basically you have to install what we call the worker, the software that we call a worker. So it's like a little bit like being a miner, if you want. So this, and then you join a worker pool or pool of workers, and then you start receiving tasks, and you're paid for each task execution. So with respect to price, so at the moment we don't know. We don't have the definitive solution for that. We have good intuitions. So what we are certainly, so first thing, we're going to have a paper task model. Task, because the good granularity for that, it's the bag of what we call a bag of tasks. If you try to do things task by task, it's extremely difficult, both performance-wise and also in terms of quality of service, etc., etc. So the good granularity is really to address this issue with at the bag of task level. And so you're going to participate to a mining pool, a worker pool. And what we're going to do is we're going to have some sort of machines that are going to be that are going to be used as a reference machines, and you can use those machines to benchmark your application, and also for machine providers, so that they can benchmark their machine according to those reference machines. Okay, and then this is going to help people to set a price for using their machine. So basically, you're going to have categories of machines, categories of tasks, and categories of applications, and so that we can sort of discretize this those different offers. And based on this, we can run a classical machine learning algorithm that will help people to have an indication of how much they can propose for renting the application. That's very important because, you know, if you, I mean, okay, it's going to be a market, but if you don't give any indication to people, because I mean, comparing machines is very difficult. You can have 8 cores, 32 cores, this amount of memory, this kind of disk, etc., etc. So if you don't give users and people entering this market a clear indication about how they can monetize their application, that's going to be extremely difficult for them to do that. So using this technique, I hope that it's going to make it very, I mean, quite easy for everyone. And so one important thing to notice is that you don't want the logic of the dApps that are going to access this infrastructure to be extremely difficult. You know, for them, it must be very, very easy. So you have your application, let's say you're developing Stockfish. So you want something quite easy to, you know, when you're developing your dApps, you know that things going to use Stockfish. So you want, you know, you want a clear indication about what kind of resources you need to run Stockfish. You don't want to, you know, to be in a solution a la eBay, let's say, where you have all kind of machines, and then you pick one particular machine to do that. It will be just impossible. So what you want is maybe some sort of categories like fast, faster, even faster, and you know that to run Stockfish, you basically need this, you know, those categories.
I mean, for Stockfish, you would want something like with a lot of like really fast hardware memory, right?
Exactly.
So you're kind of saying that users should be able to choose kind of different profiles of machines, but at the same time, it shouldn't be like that complicated where they have to be sorting through hardware. Is that, am I understanding correctly, or?
Yes, exactly. You want to have profiles of machine instead of really selecting the, you know, some particular hardware, because unless that, I guess it would be very difficult to use.
Cool. So I know you guys are, you know, we briefly touched upon this, which is the token that you use in the system. It sounds like the token is going to be kind of a transaction currency that you use to buy the computation, as well as, you know, the people who are providing the resources, the walkers, as you said, they will be compensated in that token. Is that sort of correct? And I know you guys are having an upcoming crowd sale for that asset. And do you want to mention a few things about that, how that's going to work?
Yeah, so there's a crowd sale happening the day after tomorrow. This is why I'm a little bit exhausted, sorry. I try to be as reactive as I can, but it's a bit difficult. So yeah, the crowd sale is happening the day after tomorrow. So we are issuing a maximum number of 87 million tokens, and we are selling at most 60 million of them. So the price is the basic price. I mean, the baseline is 5,000 tokens. So the token is called RLC. It means runs on lots of computers. So we like this motto. The base price is 5,000 tokens per Bitcoin. You can use a Bitcoin or Ether to buy those tokens. There is a bonus price. I mean, there is a bonus of 20% for the first 10 days of the crowd sale. And after that, it's 10%. And at the end, it's there is no bonus. So the crowd sale is set for 1 month maximum. It opens on April 19 at 1 p.m. UTC. What else should I do? Should I mention?
So it sounds like you have kind of a target raise in mind. If you're selling 60 million tokens and you're taking 1 Bitcoin per 5,000, it sounds like you have a cap of about 12,000 Bitcoins. Is that correct?
Yeah, so the cap is at, yes, if everything is sold without any bonus, it would be 12,000. And if it's sold with the 20% bonus, then it will be 10,000 Bitcoins.
So you're going for a fairly large crowd sale, it sounds like.
This is the upper limit. This is the
right,
upper
right,
limit,
of course. And what, if let's say you guys raise only like 5 million out of your limit, does that mean the tokens will be distributed pro rata to the buyers, or will some of them be returned to the company at that point?
No. So what happened is that we have a minimum objective cap of 2,000 bitcoins. So this really corresponds to the roadmap. So if you want, in the roadmap, we have several steps. So the first step is the community edition. So the community edition, it doesn't really allow to create a market. It's really just being able to do this off-chain computation because we think it's interesting. Then we have what corresponds to the minimum, what we call the minimum objective cap, which is what we think is needed to really being able to create a decentralized cloud, a market network, and so forth. So here the money is, the funds that we are going to collect are going to be used to develop the technology, to do the marketing, to create this market network. Okay, that's very important. So this corresponds to about 2,000 bitcoins, and then we have a roadmap with 5 different versions of the software that corresponds also to 5 different steps in creating the market. There's a go-to-market strategy for each step of this roadmap. So after the first step, which is the market network, as I just described, the second one is going to be about what we call enterprise edition. So the enterprise edition is very important. Basically, it's something that comes from the fact that we already have a very good experience in creating distributed computing infrastructure, and we work with many companies before, and so we already know that those companies, to access this decentralized cloud, they are going to ask for very specific feature. Okay, so at the moment, I have the feeling that in the blockchain community, this is not really addressed at the moment, but for me, I think it's really important. So just to give you an example, but the enterprises, they won't really, when you give them this ability to go on a distributed cloud, they are asking for very clear feature about their data, for instance, or their application, what is going to stay in-house, or what is going to go on this distributed infrastructure. So this is typically an enterprise feature. You want to give them a sort of a green or red button, and green button means I'm okay for this data to go, elsewhere, on a remote machine, and the red flag is no, I want this data to stay on my server. That's really important. Okay, so here we defined a lot of enterprise feature, which is about having user right management, security feature, trust feature, on all these kind of things. So this is something which is I think really important, and that's the third version of in the roadmap. The first step in the roadmap. The fourth step in the roadmap is about high performance computing. So high performance computing, sometimes people call that supercomputing. I don't like this term, because for me, supercomputing really refers to the usage of supercomputer, and that's a little bit different. But high performance computing, it's everything which is about highly demanding applications such as simulation, deep learning, and this kind of things, aeronautics, and all this sort of computation. So why do we want to do that? We want to do that because we know that there are some people in the blockchain community who have some infrastructure where you have true high performance computing capabilities. In particular, some of the miners do have such kind of infrastructure. So for instance, we have a partnership with Genesis Mining. It's a company that does cloud mining in Germany. And here they have tens of thousands of GPUs. So using those GPUs, you can really do HPC. So that's very important. You cannot do any kind of HPC. This is for sure, because the machine, the mining machine. So these are the GPUs that are used for mining for Ethereum. So of course, it's very specific because you may know, I don't know if you know that, but for instance, in the HPC area, most of the market is, I mean, it's mainly NVIDIA. And here in the mining farms, it's mostly AMD. So I mean, it's not so simple. There are issues. You must work really very precisely with in very close cooperation with the mining farms, so that at the end you can do HPC on those I mean on the miners.
Gotcha.
That's very important. That's very interesting, and I think that's something really important. And the last edition, it's really the case where we can reach those 10,000 bitcoins. Here, it's going to be about what I mentioned, at the beginning of this discussion, the future distributed application like IoT plus big data that are going to need this new form of distributed cloud infrastructure. So this is really at the end of the project. We're not going to start with this, of course. It's a more, I mean, not long term, but after 3-4 years, something like this.
Gotcha. Thank you very much for that description. I think I'll reserve my last question for Julien. So given Julien that you're involved in the marketing side of this, what do you see as sort of the most challenging kind of aspect of this project to communicate? And perhaps like what might you want some of the people who are following iExec to know ahead of your event in the next couple of days?
Well, so I think one of the challenges we're going to take, well, it's not about the crowd sale in particular, but one of the challenges we're going to take is that we're going to, listen closely to developers' requirements and deliver like an API, probably at DevCon 3. But concerning the crowd sale itself, well, it's a bit it's always a bit difficult, including for myself, to present the project and to sort of explain what we're doing. So that was pretty challenging. But I think it's not so easy to build a community starting from zero. But I think we kind of already did it, I think.
So is the challenge in communicating it kind of like, is the reason that it's sort of an infrastructure project, right? It's kind of a technical project. In order to understand it, you need to be a little bit maybe familiar with how Ethereum works. Maybe you need to be a little bit familiar with distributed computation in the first place. So do you see the kind of the best market for this, people who already have that kind of experience, or would you be reaching out to sort of like more mainstream users as well to some degree?
Well, since we're first addressing distributed application developers, we'll be focusing on that, and yes.
Okay, I mean, so do you, I guess what I'm asking is like, when you're communicating the opportunity here, are you reaching out to kind of the general crypto community? Are you trying to focus on some of the more technical folks? Like, who are your main distribution channels, I would say, right, for your market?
Well, it was basically the crypto space, say. So we try to be sort of visible on Reddit, and also I had to also be on Bitcoin Talk, and also like more classic channels like Twitter, YouTube. Yeah, pretty. I mean, classic channels, I would say.
Cool. All right, guys. Well, thank you very much for taking the time to speak with me today, this morning. I really appreciate your time. Is there anything else that you guys would like to say about the project before we sign off?
Well, so it starts. So the crowd sales start on Wednesday, 1 p.m. UTC, and you have, well, there's 20% discount.
And if people are interested to participate, they should just head over to your website. Is that correct?
Yes, correct. So
which is iEx.ec.
iEx.ec. Gotcha.
Yes,
Okay.
we're going to. Okay.
Cool. Well, again, thank you guys very much. It was a pleasure to speak with you, and good luck with your project and sale. And we hope to be testing out some chess applications on Ethereum and maybe next year.
We're going to let you know about that.
Okay, great.
Okay, thank you very much.
Take care.
Bye-bye.